Alright, Math 2. Let's take a look at these first two assignments, 6.1.1 and 6.1.2. So we're using some of the worksheet and as well as the workbook. Now normally I just had to take pictures because I don't have the electronic version, so hopefully things are clear enough and that we can do that, okay? So it asks us to find the measure of the arc or central angle indicated. Okay, so remember, when we're talking about angles, a central angle has the vertex at the center of the circle, and that this angle and this arc have the same degree measure. Okay. The other type of angle we have is an inscribed angle, okay, where the vertex is on the end. In this case, this angle, call it x, is half as the size of the arc, so that would be 2x. Okay, but we're mainly dealing with central angles right here for the first bit. All right. Okay. So this first one, we want to find what that is. Well, that arc represents that angle, so it would be 100 degrees. Just like that angle would be 125, and we could figure out this by going 360 minus these two guys, which we didn't really need to do, but just letting you know. Okay, number 2, same idea. That would be 130. And that's all we needed to do right there. Okay, number 3 wants a measure of angle LIN, so LIN would be this angle right here. So we're just going to add 50 and 51 together to get 101 degrees for that bigger one. Okay, number 4 wants HJF, so it would be this angle. Okay, so now we have the 73, but we don't know what to add to 73 to get it to work. Okay, however, we should notice that this chord here is a diameter. Okay, which means this whole side is 180 degrees. So if I subtract 73 and 51 from 180, that would give us that missing degree. So it would be 56. So 56 plus 73 degrees would give us 929 degrees. Okay. All right. Now for 5 and 6, we're solving for x. Okay. So if I look at this one, notice we have angle measures for every single angle there. And a full circle equals 360 degrees. So we'd simply add them all together and set them equal to 360. So 75 plus 125 plus negative 39x plus 1 plus 36 plus x plus 86. Okay, so then we combine all the like terms, so x and negative 39x, okay, would give us negative 37x. Then we combine all the numbers. 75 and 125 would give us 200 plus 1 plus 36, so 201 plus 36 plus 86. So that would be 12, 13. That would be 11, 12. So 323. So we'd have negative 37x plus 323, and that would all equal 360. So we'd subtract the 323. And we end up with, that would be 7. That would be 3. So 37 equals negative 37x, divided by negative 37. We get negative 1 equals x. So that's all they want us to do is find x, and it's negative 1 right there. Okay, now if we look at number 6, we've got another diameter here, so we just add those. 60 plus 68 plus 7x plus 3. And we know that that's going to equal 180. So 7x plus 60 and 68 would be 128 plus 3, 131 equals 180. Subtract 131. And we get 7x equals, that would be 9 and 4. So x equals 49 divided by 7, and x would equal 7. Okay, now in 7 and 8, they actually want us to go one step further once we find x. They want us to figure out what the measure of the arc or central angle indicated would be. Okay, So we're assuming that lines which appear to be diameters are actual diameters. Alright, so we want angle AFE. So in order to do that, we need to figure out what x is. Well, we've got a diameter right here, so I can set those two, add them together, and set them equal to 180. So 10x and 3x gives us 13x, plus 10 and 14 would be 24, equals 180. Subtract a 24 here, and we get 13x equals, let's see, that would be 6, 56, 156. So we divide by 13, and we get x equals, actually let's scoot this down a bit, so we get x equals, and we get 12. So now, since we're looking for this angle, we just plug in 12 for x to find our answer. So 10 times 12 is 120, plus 10 would give us 130 degrees. And that's what we were going for. That's the measure of angle AFE. It's 130. Alright, now let's do the same thing here. So once again, we've got a diameter, so we can use that to solve for x. That would equal 180 degrees. So 12x and 18x would give us 30x. 51 and 7 would be 58, plus 2 would be 60, equals 180. We subtract 60 from both sides. So we get 30x equals 120, divide by 30, and x would equal 4. So if x equals 4, then for angle GDI, that would be GDI, would be that whole angle. So we got to find this one first. So we go 18 times 4 plus 2. Okay, 18 times 4 is 2, 3, 4 times 1 is 4, plus 3 is 7. 72 plus 2 would give us 74, plus the 51 would get 125 degrees. That's the measure of angle GDI. Alright, let's keep on trucking. So 9 and 10, same idea. Even though these are arc measures, we treat them the same way. So SQT, we want to get that angle, which means we need to figure out what x is. Now we know that this is 115. We know we've got a diameter here. So 180 minus 115 is 65, so this would be 65 degrees. Now, if you notice, those are a vertical angle, form that x, so this would also be 65 degrees. So I know that these three would add up to equal 180. So 65 plus x plus 73 plus x plus 48 equals 180. So 65, 73, and 48, we've got two x's. So 65, 73, and 48 would give us, it's 8, 16, 14, 18, so 186 equals 180, subtract 186. We get negative 6 equals 2x. Divide by 2, and we get x equals negative 3. So to go back to this angle, it's x plus 73. So negative 3 plus 73 would give us a degree of 70. And there's 9. There's number 10 would be the last one on the worksheet because the rest of the problems I don't want you guys working on. So EBF would be this angle right here. So once again, we need to figure out x. Now it looks like we've got a piece for everything. So this is going to be one of those big ones where we add it all together. So x plus 88 plus x plus 70 plus negative 10x plus 5 plus negative 5 minus 22x plus 52. And all of that is equal to 360. So let's simplify here. So our x's, we've got two x's here, minus a 10x, minus a 22x. So 2x minus 22 would be negative 20x. So negative 10x minus would give us a negative 30x. Okay, then our regular numbers, 88, 70, positive 5, negative 5 would undo each other, and 52. So 0, 1, 15, 21, so 210. So plus 210 equals 360. Subtract 210, not 220. And we'd get 150 divided by negative 30. And x would equal negative 5. Okay, now that we know what negative 5 is, or x is, we take this, and we go negative 10 times negative 5 plus 5. That would be positive 50 plus 5, so we get 55 degrees would be our EBF angle. Alright, now there's a couple problems I wanted you to do, so we're here on this practice 6.1.1, which starts on page 13, but our problems are on page 14 and 15. So there's only 3 problems I wanted you to work. You can try more, but we're doing number 5, number 7, and number 10 from those ones. Okay? So we want to find x and y. So now we've got some inscribed angles. So this angle here would be inscribed, and it would match up with this arc right here. So this is twice as big as this angle, so we cut that in half, so x equals 75 degrees. Okay. Now we've got a vertical angle here, so I know that's 32 degrees. I know x is 75 degrees. So I also know that this triangle is going to equal 180. So I go 180 minus 32 minus 75. Okay, so that would give me 8 and 4, 148. Minus 75 would give us 3, give us 73. So y going to equal 73 degrees. Okay, number 7. Once again, we've got some inscribed angles here. So we need to know what x equals, what y equals, and what z equals. Z is a good place to start. Inscribed angle here. So that tells me that half of 63 is going to be z. So 63 cut in half would be 31.5 z. Be 31.5 degrees. Okay. X is opening up here, and it's going to be half of y. Okay, now if I notice, you should notice that y here is half a circle, so it's going to be 180 degrees. And since x is the inscribed angle for that one, we cut it in half, and it's 90 degrees. Okay, number 10, it says find arc BC. So that would be BC, not BAC, so we don't go around that way, because it's a minor arc. So the measure of arc BC, okay, we have an inscribed angle here, 48, so we double it because it matches up with that arc, and 48 and 48 would give us 96, so BC would be 96 degrees. Then we want to find CA. Well, if we notice, BA would be 110, BC is 96, so if we add those two together, we would get 206, which would be AC. So measure of AC or CA arc, 206. And if we wanted to find this angle, we just cut 206 in half, and that would give us 103, if we wanted to go that far. Alright, so now let's take a look on page 25. Now we're going to look at the 6.1.2. So it says in circle A, the measure of BAC is 64 degrees. What is the measure of arc BDC? So now 3 letters, different than 2 letters, so this makes it a major arc. So we know that this would be 64 degrees because it's a central angle. So I go 360 minus 64, and we end up with 296 degrees. Okay. Now on number 2, they want us to go backwards. So they told us BDC, arc BDC. We want to find BAC, which means we want to find the rest of that arc. So again, 360 minus the other arc, and that'll give us everything we need to know. So we get 122 degrees, which matches our angle, so measure of angle BAC is 122 degrees. Alright, now number 3, because we're doing all 10 of these. Now, sorry that the picture, you can kind of see the pages are pretty thin, aren't they? So now we've got this for our central angle, and for the arc, this. Well, these two, it's a central angle, so they're the same. So I simply set them equal to each other, and we solve. So I could add a 4t to both sides, giving me 6t minus 3 equals 9, add a 3. So 6t equals 12, divide by 6, and we get t equals 2. And there we go for that one. Okay, now 4 says in circles G and E are congruent. What can you conclude about circle G and circle E? Okay. So we've got this chord here, right? Which tells us that this arc is congruent with this arc. You can also make that central angle, and the central angle would be congruent. Okay. We can also, because it says they're congruent, we can also determine that these radii are all congruent. So we've got this whole triangle here that's congruent to this triangle. So that's kind of all the main stuff we can say about that. Number 5, is there enough information to conclude that the central angles of the chords are congruent? No, because these chords aren't congruent. So therefore we can't determine that these are congruent, and therefore the angles are congruent. So no, we can't. Nothing is congruent that we know of. Could be, but we don't know, so we can't say anything about it. Okay, number 6. So now we've got congruent circles, which would make these central angles congruent, because they told us. So this one's 64, so that would be 64. So we simply go 64 is equal to the 2y minus 6, and we solve. So we get 70 equals 2y, divide by 2, so y equals 35 degrees. And that's what we can say about that one. Alright, number 7 and 8, we want to find the value of t. Okay, so we're dealing with these angles now because of these chords being congruent. Okay, we know that these arcs are congruent, which also tell us that these angles are congruent, so we can set these equal to each other. So 6t minus 12 is equal to 18 minus 4t. Add 12. That'll give us 30. Add 4t to both sides. Give us 10t. Divide by 10. And t equals 3. Because that would be 0. And that would also be 0. Okay, for 8, because those are congruent, we also know those arcs are congruent, so we set them equal to 0 again. Or not equal to 0, I don't know where that came from. We set them equal to each other. So we get 4t, subtract 2, equals 92, divide by 4. We get t equals, let's see, 4 goes into 9, twice, 8. Bring down the 2, 4 goes into that 3, so 23 times. So t equals 23. Alright, finally the last two, number 9, same idea here. Okay, this we know is congruent to this, which means this is the same as that, which means these two are congruent. So once again, same process, we just set them equal to each other. I guess when in doubt on a circle, just set them equal to each other. Add 2t to both sides. Negative t plus 2t would just give me 1t. Subtract 15. And 23 minus 15 would be 8, so t equals 8. Okay, now number 10 says the circumference of the trunk of a tree, to be decorated is 12 inches. Okay, so we've got a trunk. The circumference, so that length around, is 12. You have 7 inches of garland to wrap partially around the tree trunk. What is the arc angle of the trunk that you will decorate? So, we've only got 7 inches of garland to wrap around here. Okay, so they want to know what the arc angle of the tree you will decorate. So what's the degree measure of that? Okay, so this one we're going to have to think proportionally. Okay, I know the circumference is 12, and I'm going to use 7 of it. Okay, now let's switch that to degrees. That 12 circumference is the same as 360 degrees. Now, my angle measure that's equal to that 7 inches, we don't know what that is. But by setting up this proportion, I can then cross multiply. So 12 times question mark would equal 7 times 360. So, and 7 times 360 is 2,520. Then we divide by 12. So divide that by 12, and we get 210. So, our 7 inches takes up a degree arc of 210. Alright guys, so there's those first 6.1.1, the worksheet and the book work, as well as 6.1.2, the book work. And there we go.